Okay, now I can share my. First thing when you try to do the program, I recommend your program supposed to display the line number. Okay. The thing is when you're asking me, need help, easy to help you out. In order to get the line number displayed, first thing in your menu, you select the tool. Then select the text editor. Then you select the C++. And then the last one, select the line number. So everything you get into your C++, you edit your program, they will be automatically given you the line number. That will be help, not for this program, will be for any time you want to using this software. Okay, any question? Okay, if it's no question, then now I will be talking about DLAB11. Okay, so basically this schematic. When you're looking into the schematic, try to understand HIC, how they working. We already get through for your guide, okay? For example, for the first one, you can send the binary in serial, and they convert it into the output here will be parallel. You understand inside the computer, they're not using serial, they're using the parallel, okay? This IC 164, 8-bit serial to parallel. If you need 16-bit, then you need 2 IC. And more, then you have to add in more IC. However, in the computer, they're using binary. In order to get the binary going serial to parallel, I already get the function. You just call that function. You say send serial 0x55, then you get 0x55 here. Or AA, you get AA here. Or any binary 8-bit serial, they convert it into the parallel. Okay? And the second thing, U3-541 buffer. And the buffer will be, input will be equal to the output. you get logic 1 in input. Number 2, you get logic 1. Output 18 with U3 pin 1, pin 19 must be 0. And basically that will be controlled by U4A, that decoder. Okay? And you have to know how the decoder working. So when you measure U3 pin 2 logic 1, but you not get U3 pin 18 logic 1, you have a problem with that guy here. So you can check pin 119, make sure they be 0. If they're not 0, you go back. U4 pin 4, they must 0. If it's not, then you have to check input A, input B, and pin 1 must be routed. That is how to troubleshoot it.
U3 is just data D1 straight over to Q1, right? It doesn't change.
U3 is just a buffer. That means if you let logic 1, U3 pin 2, 2.5 volt, 3 volt, logic 1. However, when they go to U3, they increase more current. So pin 18, they can be up to 4 volt, still logic 1. But that's the purpose for the buffer.
So it'll help the rest of the circuit then, right? Understand.
Okay. So instead, you have to do line by line for everything. We don't want that.
And Mr. Pham, you were saying that pin 2 could be 3 volts and pin 18 could be 4 volts, but it's still logic 1.
Exactly.
Okay, and it still works the same.
They much better.
But U3 most significant usage of U3 IC is mainly for current, correct?
Yeah, try to increase the current. Try to bring the logic to the standard logic.
Right. So if it's 1 on pin 2, it'll go 1 on pin 18. And
but
then
the different voltage.
right, it'll just buffer it. And then it's mainly an amplifier IC then, just for current then.
Yeah, the thing that they try to bring up the logic to the standard. You understand that mean what? Logic 0. They wanted 0 volt, 0, 0.1, 0.2, 0.3, 0.4. Okay, 0.5, 0.6, 0.7, 0.8, still 0. But they don't want that. They want to be 0. Or close to 0, that's perfect. And logic 1, we already define from 2 volt up to 5.5 volt. Logic 1. And they using the buffer, they want to bring to the standard. Logic 1 is 5 volt. So output, they can be 5 volt, maybe 4.5, they can be 4 volt of 3.5. That's much better. So the first test very simple. You send the series going to U1, go to U3, they go to U2, and computer port C, they will be read it and telling you right or wrong. That's the test one. Only relate to U1, U2, U3, and U4. So that's why in my test, the first test, okay, the first test here, okay, let's see. Test number 1, I already said test U1, U2, U3, U4 with the data 5.5. anything wrong, that means only U1, U2, U3, U4 got the problem. That's how to narrow the thing so you can troubleshoot it to figure out what's wrong. In the test number 2, we test almost the same thing, but the data now will be AA. However, on the P-COP, now you can say I get U1, U2, U3, but not see U4. Who knows why? And the first test for that, some wrong can be U1, U2, U3, U4. However, for the same, with a different data, pick up only U1, U2, U3, but not U4.
Because you already checked U4 when it passed the first one.
Exactly.
And when you passed the first test, U4 had to be working because you had a logic 0 at pin 4, and it went to U3 pin 1 and 19, and it was active low there, and it worked there. So therefore, if it worked for U1, I mean the first test, it should work for the second test.
Exactly. The thing is, the second test they just changed from 0, 1, 0, 1, 0 to 0, 1, 0, 1. Okay. Then this one can pass the first one, U4, pass the first one. On the second one, they still be good. Only wrong will be U1, U2, U3. I already telling you. In the digital, it's the input or the output, they must test with both logic. Like example, U3 pin 2, we test logic 1. On the first test, on the second test, you must test logic 0. So that's why sometimes you can see, we test the data 5.5, then we have to test data AA. Okay, so normally in the test program, we using the function. First, like I want to send serial data here. I did the function, we already did it. I gave it to you. You said, you want send 55AA. You call that function, they do it for you. And now, in order for the U3 input to the output, I need pin 119 to be 0. So that's why I put in the function we call enable U3. Function enable U3 just telling to you U3 pin 1 and 19 have to be 0. Okay? That is the way. Instead, you have to write line by line. Then we better do a function. Only when we read it, that makes sense to you what we are doing. Another example here. You can see U8 memory. Memory, they get a binary address right here. And that is the output. Okay. So in order to write data to the memory, you must get the address. And you have to get data. That's a very simple thing. When you write to the memory, you have to let them know which location you want to write it. Okay, and what the data. Then you can talking about writing. So now if you say on it, I say 6116. How many in address input? You can count here. A0 up to A10. So A0 to A10, that means you get 11, right? 11 wire for the input. So in general, what the size of the memory? How many words? If you see the address lines, can you tell me how many words for this memory?
2 to the n, 2 to the 10.
10 or 11? Two to the power of 10 or power of 11.
Should be 11.
Exactly. The thing is you start from A0. If you count the wire, 1, 2, 3, 4, 5, 6, I believe 11 wire. How many locations? What you get to the power of 11?
2048.
Okay. That means they get 20,
48.
48 word. Okay. And how many data per word?
Oh, you got 2, 4, 6, 8.
8, correct. That means the size of this memory will be 2048 K, right?
Mm-hmm.
By 8. The thing I want you to know, the thing is when you're working in the company, you get a schematic. So you can see into the memory, you can understand how many words they wanted and how many data bit per word. Okay, however, for this lab, we're not using 1, 2, 3. We get only A0 to A7. So what is the maximum location will be tested? How many maximum location on this lab will be tested? Due to the what power?
$32.
8, right? So basically we only test up to 256 location, not up to 2048. The thing is we routed. Okay. The memory, very simple thing. You just write data to a certain address. Later on, you go to that address and read it back. Say what you did routing into that location. When you take it back, they have to be the same. Now, I try to bring it up to one thing for you to see. U5. U5 here, basically address. for the memory. So if you want to write data to the memory, first thing you have to set the address right here. Okay. Then in order to do it, you have to write serial data. I say address AA, then you send AA here, and you enable U3. So that will be going to here. Now, what we want this input data will be go into here. How can we do it?
You got a latch pin 11 with a high.
Okay, let LE, latch enable, U5 latch. That means you must be set U5 11 to logic 1. Okay, when you set data LE to logic 1, whatever here, input go inside U5. And if you want data inside go to output here, pin 1 must be 0. And now we route it. That means everything when they're coming in, they're coming out. So when LE at the logic 1, they will be get the address here. If you get the 0 LE, then whatever here cannot go inside here. Okay? The thing that you understand the design, they sharing that wire. They sharing wire here. They sharing the wire to U6 and also U7. So every time you change a data output U3, if you want to go to U5, then you set to 1. If you don't want it, and they will be 0. Okay? That's how it works.
Because you made the output enable, you made it logic low. So anything that, as long as enable is 1, stuff will go through. But if if pin 11 is 0, then nothing will go through.
Exactly. That's how I see working. LE 0. Whatever here, whatever it was, they still be the same. The thing that you see the wire here, 8 wire. Okay, they go to U6, see that? And they go to U7. So basically depend, you want to go to the U6 or, you want output from U7. Depend on, for example, U6, you get the data right here. If you want it to go inside U6, then you need to apply the clock to U6 pin 11. 0 to 1 transition, they go inside. You can get data here changing, but if you don't have a clock, they cannot get inside U6. And when they get inside U6, you want to go to the output U6. You need to apply U6 pin 1 to be 0. Output control, 0, whatever inside go out. And that will be the data to the memory. They go to U8. Okay, they go here. That is how you can write data to the memory. And when you're reading out of the memory, you must be apply a thread first. Okay, then we can set it reading. So data coming out, they will be coming out right here. That's the output of U6. Okay, and they also go to the input U7. So you want the data go to U7. And the data output U6 must be disabled. That means, look like you don't have a U6 here. They will be go this way. Go to port C. That everything for the tab 11. That's the hardware.
Hey, Mr. Pham, so the main thing with U5 and U6 is on the U6 clock, if you don't have a clock, the data don't even go inside of U6 yet, right?
Correct.
It stays outside of U6 until the clock
Right.
lets it go in.
Yeah.
Okay, thank you, thank you.
And they already in, but they're not out. Until U6 pin 1 must be low.
Oh, okay, so you're saying the data actually goes in U6, it's just that it doesn't go out until pin 1 is low.
Exactly.
Okay, thank you.
And also the same thing for U7. When you're reading a memory, data will be coming out here. They ready right here. However, you want to go this way.
Right.
So you can reading from port C. In order to do it, Q7 pin 1 and 19 must be 0. That means you have to know how we make it to be 0 when you read it. Okay? That means you're supposed to get U9 pin 4 to be 1 and U9 pin 5 to be 1. So that's why you get 0.
Mm.
That's the whole circuit. And everything we put in here. Okay. Now, 14. This is, I already gave it to you. And what I try to go into the software. Okay. I'm telling you step by step so you're able to do it. Let's see. So
All they got to do is add the void to the front and the semicolon on the rear, and then they got it.
yeah, I'm just telling you.
And then that'll be the prototype. And for the function definition, put it outside the main at the bottom without the semicolon.
Let's see. Okay, let's see. Okay, I got a new project. I can say DLAB11 sample. I believe everything here you guys already know how to do it. Okay, so basically, anyone you can do line number 1 to line number 5. Okay, and now in line number 6, I don't care what is in here. Okay, I just put a comment here. Okay, that will be prototype area. So that will be telling you if you get any decoration for function, then you will be put in here. Okay. Now,
Below line 6.
yeah, I go in low. And after that, I can say use stack main program. Okay, then you can say void main. Okay, open. Okay, close. Then you open the brace. Okay, so basically your program here. Okay, then now you're going down. Okay, after that, that will be in main. Okay, so basically you can see the way the program organized. Now I want to copy that one here. Okay, yeah, this part here. We need that. Okay, so that means your program will be start from here, void main, and you can type in that number 1, number 2, number 3 in here, everything, and then you get a end of your main. Now, the next one, that will be function definition area. Okay. So if you get any function in the prototype, for example, this one, then you must get the function definition in this area here. Now, I can go into here. I'm looking for serial right here. I can copy that. Okay. Copy that guy. And I go into here. Paste them out. So that is the function definition for the serial. Okay. Now, I'm going back to the function prototype. You can see on the Excel, I already given to you here. See that? All of the function prototype. Copy and paste it into your C++. Okay. Now, when you copy that, you have to know they will be void, right? Void. This is the name. And they must be end with
Semicolon.
semicolon. And the next, same thing. And with semicolon. The next, same thing. Void. Okay, that on off the function, that prototype, I already gave it to you. Only thing is you know how to copy from Excel and put it into your C++. So any question up to this point?
Delete line number 8.
Right. That will be void, right?
But you already got it up top on line 7.
Okay, so we delete that. How come line number 8 we get the red underscore under that?
Maybe you got it somewhere else.
Can you look at line 7, go all the way to the right? Maybe you have something additional to
That's
the right.
okay now.
Okay.
Okay, so basically that is, you know, right now you don't understand what is add function. But that's what I gave it to you. You can copy from Excel and put it into your program. But I want to know if you get any question or anything you don't know how to do it. And we get a lot copy in order to put it into the prototype area. Let's see, I get here or not. They're not in here, so maybe they're in here. Right here,
Oh, the array?
exactly, right here.
That goes before the main, right?
They on the prototype area.
Right,
Okay.
right.
Copy that one, and you can put it here.
Mm.
See that? Okay, that an array for now. So that is done. And basically, on this part here, we start on the main. But I'm not doing anything on the main yet. What I try to tell you, you get the function prototype and you need the function definition. Okay, so you can copy that. Okay, and you go into the function area definition area. Okay, that function definition. And you want for that to put them out. So void, okay? So
Get rid of the semicolon.
yeah, exactly. But what I want to see, I can put a comment here, okay? Function definition of enable
Enable U3.
U3. Okay, the function definition, they exactly the same like in the prototype. However, they don't have a
semicolon.
semicolon. And you press enter. Okay, so you get to open the brace and will be closed.
The other brace, Mr. Pham,
You can see right here. Oh,
the,
sorry.
the other
Oh.
brace.
Yeah. They have to be open the brace. Right?
Yep, that one. That's the one.
Then they must be closed. So that will be telling you and of function. See, my computer, how come they can be slow?
I thought you typed 90 words a minute, Mr. Pham.
Function.
Basically, just copy paste function definition, enable U3.
And of function.
And
Okay.
then, yeah,
Oh man. Okay. So that's done for that one. Now, what will be inside the function?
whatever it takes to fulfill the requirement of void enable U3.
So that's why you need to look into here. I already gave it to you. You see, first, number one, enable U3. Only thing you need to do is write to port B, data 00. So basically, you can say write to B, open 0800. This semicolon here or comma?
Comma 0, comma.
Comma.
Comma,
Yeah.
and then 0. No, a comma, Mr. Pham.
Yeah. Let's see, that will be comma 0.
Then
Okay.
then semicolon after.
Exactly.
That's it.
That's only one. You see that? And now that you have to do, okay? That means you have to add in function definition for each one. And everything already show you in here. You say that you seek output enable. You write to port B 01. U7 output enable. U5 latch. U6 lock. That U6, U7 data. Okay. Try address to memory. First thing you write to port D01. Then you go enable U3. Serial data bit 1. Whatever address you want. And U5 last. Write data to the memory. You just follow it. And you can get it done for your function definition. Okay. For that, validate. Okay. Basically, on that one, they say measure data, read port C, test evaluation, if no go L. Instead, you typing on each tab, measure data equal, test evaluation, if no go, fail or pass. Then you don't need that validate. They want to do it, they want you can type in only one line and they do the rest. Okay. If you want to make your program more clear, then you just using measure data, read port C, and test evaluation. Okay. And here, test memory ADC data. I already did it for you. Okay. So you can copy that one. Okay, copy that. I want to do for this one. Go to edit, go to this one here. Okay, we can put couple. Let them out. Basically, that will be void, right?
Right.
That's the function. Prototype. And now, before you start void, then basically you have to open break. And that will be a for loop. Okay. Then now you go back to here. Copy everything here. Okay. To the end of that one. Copy. Now going back here. Okay, paste them out. So test memory ADC data. Okay. The first line, they want to going from 0 to 42. They write display message so they can tell you. Okay, they will be right to what address. So they call the function write address to memory per J. Okay, J means J equals 0, location 0, J1, location 1. Okay, and so on. Then they get the ADC data equal the array ADC data per year. That means they get the data, the first, okay, of the array. You see, the first data will be 0899. Okay, and they have to do 42 times up to the end. Okay. So after you get data ADC data from an array, now they will be drive that data to memory. That is ADC data. So basically you can see you apply a thread to memory, ready. You apply data to memory, ready. Then you call the function write to memory. So they will be keep going for 42 times. Okay. And after they done, now you need to reading ADC data from memory. Okay. And also you still have to using for. Okay. However, before the for, okay, you can take that one out, duplicate it. Okay. And then
Do you need to get one of those brackets?
there, that out, right?
Okay.
So the first one, that number. The thing is when you go to the loop 42 times, if you are not using the increment the that number, then they not display the correct that number. Then you want to read, you have to set a thread first. Same thing. They start from 0 to 42. And they pack the data. Expect the data will be from ADC data array, and you read memory. After you read it, you measure data, that evaluation, if no go, that part or fail. Okay. Then when you're using reading data, you get open. Okay, and you need to close. And this is a close here. That will be close for
The function
function
definition.
definition. The thing is, if you wrong open and close brace, they get to giving you a lot of error. Okay. Now that is the one we already done. The last one we want in the Excel here. That memory in a random. Okay. You can copy everything here. The thing is, you don't have to do anything on that thing. Just make sure you get the right data. Copy. Now go into here. Paste them out. Okay. Void. That memory random data. So basically, you don't have to do anything. I believe so. Okay. Then now, in your test, program here. Your test program here. Okay, man here. Okay. Then I can go into here. Okay. I can copy. You have to do it. Okay. But I can copy the test here. That's number one. That's number one. You can copy that.
Oh, this way you do the test 1 through 6 or 1 through 7.
Yeah. But I do only one.
Okay, yeah, I get you.
Okay. So you start with that number one. Title, expect, math, pick up. You call the function here. Okay, enable, you tree, and make your data go, no go. Okay, and that will be try to do with the that number. You will not do it. Okay, I will be do for that number 3, 4, 5, 6. Okay, I doing number 6. Copy number 6. Copy that one. Okay. And I paste the number 6. That number 6. Now, after the test number 6, okay, you can see that number 6. Okay, basically 1, 2, 3. No,
That's not it.
that number here.
Yeah.
Okay, that number 6 here. That number ADC test data. Okay, so basically we already get the function. So only thing you need, okay, call that function. Right here. Copy. And now you just paste them out. Okay?
Hey, Mr. Pham, I get what you just did there. So basically, after test number 6, you just did what I was talking about. You put the test memory ADC data and the test memory random data. Those are just you calling the function.
Right.
For both of them. So
Exactly.
after 6, you just put those 2 like that, and you're done with the program.
Right.
Gotcha.
That's why when you're using the function,
Right.
you don't have to tie everything in here.
Right.
You just call that function, they will be doing 42 tasks.
Mhm.
Okay?
Gotcha.
So basically what else you need to do, you need to add it. Okay? function prototype for the rest. Okay, now if you see I try to combine, rebuild it. Okay, I just try to build it. You can see we can get the error. How? See that? They can say right here. Okay, when you click on the red one, it shows you get error right here. Okay. Then that's what we need to fix the error. However, in order to fix an error, you have to complete all of the function definition. Okay, up here, depending on how many function definition here.
Because one function definition might be somewhat related to another thing in the program, and you need to have it all there, correct?
Right. You must be get already the function definition.
What is line 13? Line 13.
Enable. You save it. Okay, two things. If you're looking into schematic here,
Right.
in the test program, if you say test U6U7, then you don't have to using enable U6U7. What enable U6U7? They're telling you they writing data to output U6, then also they enable U7 so you can verify output. So if something failed, can be U6 or U7. Make sure U6 can be get the right data coming out. U7 can read the right data coming in. In order to do it, then they have to set enable, output enable, U6 pin 1 0. Also, output enable, U7 119 to be 0. So that's why they're coming out, they're coming back in. In order to do it, you have to set PB06 here to be a 1. Okay? 1 in here, the 0. And you get 1 and the 0 and 0 here. So you get a 1 in here. They will be 0 here. In the test program, I already get the function test U6, U7. Inside this function, we don't need enable U6, U7. If you call this function, okay? If you want to test step by step, then you need enable U6, U7. Let's see, I want to show you in here. Okay, you can see that number 1, number 2. Okay, number 3, U6, U7, data 55. Now, If I call the function that U6, U7, 55, that's it, nothing else. The thing is inside U6, U7, you get everything. Also include that validate. Okay, so you don't need to say read proceed. Now, on my, I put the comment here telling you that means in the test U6, U7, that's what I need to do. First thing I call that serial. Data 0855. Then I enable U3. Then I apply U6 clock. Okay. Then I apply U6 output enable. Okay. Then I need to write to port B21. That will be inside the function enable U6, U7. Okay.
So, Mr. Pham, just a quick question. What you're saying is lines 121 all the way down to 129, they go together and they can replace those few lines above 121. In other words, use one or the other.
Okay, from line to 121.
Right.
Up to
129.
now, up to here.
Oh, I'm sorry. Yeah. Up to 135.
Right. That
Those-
means everything include
Right.
into the function. That U6, U7.
Right. So you could write, you could either write line 120 by itself, or you could write 121 to 135 to replace it.
Exactly.
I got you. I got you. So it makes it's better to just write line 120.
The thing is, when you're reading from line 121 now, right?
Right, right.
More clear.
Yeah, you can understand everything that's there, but it's a lot more writing.
Yeah. Instead, you're using that one function, one line. Okay.
Line 120 replaces line 121 to line 135.
Right. The line 120 replace from line 121 up to 135.
Right.
That means everything here include inside that guy.
Right. Got you.
Okay, now another thing I can recommend you. Every time you typing in, I say enable E3, you better put the commands. What that doing? You see that? Like here I say allow data to output U3. Or if we say U6 clock, what that happen? Clock to U6 pin 11 to whatever, you see?
Mhm.
U6 output enable. Set U6 pin 1 to 0. So the thing is you understand, especially if you're working for government, every line they asking you to put a comment. What are you doing? in the class, I want you to get the comments so you know what's going on. Okay. If someone else is reading the program, they able to understand what are you doing. So again, what I'm saying is try the best you can to get this software done. Okay. If you send to Sam and he said fail and you believe your program is dry, then let me know. I will be download your program and run with my hardware and try to see what the difference between me and Mr. Sam and let you know.
Hey, Mr. Pham, just do me one baby favor. Make sure you put this lecture on the web tonight so we can look at the tape.
Upload it tonight.
Yeah.
I will.
Okay, thank you.
The thing I need your guys really understand what you're doing. You get through this lab and the rest of the lab will be more easy for you. You just copy from 11 and paste it into number 12. Just adding a little more. For example, that number 12 will be D to A converter. But we're using most of the circuitry, same thing in the TET 11.
You mean lab 11 and 12?
I'm using most of the part in the lab 11 for the lab number 12.
Yeah, right.
Only thing I adding part of the D to A converter.
Right.
So you're done with this software, then the next one really easy. Okay, any question, anything to me?
Great job, Mr. Pham. Great job. You explained that well. Thank you.
You understand? I have to think it every time when I try to give the lecture based on some student online with me asking about the lab. I try to figure out how the better way in order for the student can do it. Only thing they don't want to do, I give up, okay? But they really want to do, they don't know how to start it. So that's what. I'm not done before, like before long time ago, I never. You see that? Before you come into the class normally, I never spend time too much in teaching for you guys how to do your program. But you still get it done. Okay, any question to me?
Just upload this puppy tonight, Mr. Pham.
So, try to get your software. I don't care about hardware for now, but the software have to be done. Okay, right now, we on May. So we get 3 more weeks, then we go to June, and another 3 more weeks. Then we'll be done for the spring.
I'm gonna let Sam and Kumi do mine. They laughing.
Only thing it's going to do, you must try understand what happened, what's going on, how can you do it? I need to your guy to understand. Okay? But it failed to me, that doesn't matter. Only thing is you really willing to do or not. Okay? Any question, any more? If it not, okay, then will be good night, everyone.
Good night, Mr. Pham. Thank you.
You're
Thank you.
welcome.
Good night, Mr.
Good night.
Pham.
Thank you.